A database is an organized collection of data, typically stored and accessed electronically from a computer system. Databases make it easy to store, manage, and retrieve data. They are vital for various applications, from business systems to web applications and beyond. Key concepts of databases. 1. Data. Definition: raw facts and figures without context. Examples include numbers, dates, and strings. Types: text, numbers, dates, images, audio, etc. Number 2. Database management system. Definition: software that uses a database to provide functionalities like data storage, retrieval, update, and management. Examples: MySQL, PostgreSQL, Oracle, Microsoft SQL Server, MongoDB. Functions: data storage and retrieval, data manipulation, CRUD operations, create, read, update, delete, data security and integrity, backup and recovery. 3. Database models. Definition: the structure or format in which data is stored, organized, and manipulated. Types: relational model uses tables, relations to represent data and relationships. Examples: MySQL, PostgreSQL. NoSQL models: document model stores data in document format, JSON, BSON. Example: MongoDB. Key value model: data stored as key value pairs. Example: Redis. Column family model stores data in columns rather than rows. Example: Cassandra. Graph model stores data in nodes and edges, representing entities and relationships. Example: Neo4j. 4. Schemas. Definition: the structure that defines the organization of data in a database, including tables, fields, and relationships. Components: tables, collections of records, and columns, fields. Fields, columns, define the data type and attributes of data. Records, rows, individual entries in a table. Primary key, unique identifier for each record in a table. Foreign key, a field in one table that uniquely identifies a row of another table. 5. SQL, structured query language. Definition: a standard programming language used to manage and manipulate relational databases. Operations: DDL, data definition language, create, alter, drop. DML, data manipulation language, select, insert, update, delete. DCL, data control language, grant, revoke, transaction control length, commit, rollback, save point. For 6. Indexes. Definition: data structures that improve the speed of data retrieval operations on a database table. Types: primary index, automatically created on primary key. Secondary index, created by users to speed up queries. Unique index ensures all values in the index are distinct. 7. Transactions. Definition: a sequence of operations performed as a single logical unit of work. Properties: acid, atomicity. All operations are completed successfully or none at all. Consistency: the database remains in a consistent state before and after the transaction. Isolation: transactions are executed independently. Durability: once a transaction is committed, it remains so even in the event of a system failure. 8. Normalization. Definition: the process of organizing data to reduce redundancy and improve data integrity. Normal forms: 1NF, first normal form, ensures each column contains atomic, indivisible values. 2NF, second normal form, ensures no partial dependency of any column on the primary key. 3NF, third normal form, ensures no transitive dependency of any column on the primary key. 9. Data integrity. Definition: the accuracy and consistency of data within a database. Types: entity integrity ensures each table has a unique primary key. Referential integrity ensures foreign keys correctly and consistently reference primary keys. 10. Backup and recovery. Backup: creating copies of data to restore the original after a data loss event. Recovery: restoring the database to a correct state in the event of a failure. 11. Database security. Definition: measures to protect the database from unauthorized access and ensure data privacy. Techniques: authentication, verifying the identity of users. Authorization, granting or restricting user permissions. Encryption, converting data into a code to prevent unauthorized access. Hacker 12. Database administration. Role: DBAs, database administrators, manage and maintain the database systems. Responsibilities: installing and upgrading the DBMS, monitoring performance and tuning the database, implementing security measures, ensuring data backup and recovery. Now 13. Distributed databases. Definition: a database that is spread across multiple locations or computing devices. Types: homogeneous distributed databases, same DBMS at each node. Heterogeneous distributed databases, different DBMS at each node. Advantages: improved reliability, availability, and scalability. 14. Data warehousing. Definition: the process of collecting and managing large volumes of data from different sources to provide meaningful business insights. Components: ETL, extract, transform, load, process of extracting data from different sources, transforming it to fit operational needs, and loading it into the warehouse. OLAP, online analytical processing, tools for querying and analyzing data in the warehouse. 15. Big data and NoSQL databases. Big data, extremely large data sets that cannot be managed with traditional databases. NoSQL databases, designed to handle big data and non-relational data models. Understanding these concepts provides a comprehensive overview of databases and their management. Databases play a crucial role in modern technology, underpinning everything from small applications to large-scale enterprise systems.